Hi, so in this video, we're going to start working on advanced financial modeling. And the first unit of advanced financial modeling is going to talk about introduction to financial modeling. Essentially, what is financial modeling? Uh, we'll try and do a little recap of what we've already done in Excel. We will try and understand the objective of financial modeling, essentially the idea of why models should be accurate, flexible, and user-friendly. We will try and define model objectives and see how do we set up models in various segments, various scenarios in finance. We will look at identifying, the process of creating a model, which is essentially first finding out what is the objective, then identifying the inputs, then going to deliverables, what's going to be the output, doing some sort of stress testing or scenario analysis around those, and then eventually documenting the key parts of the model so that someone else can also look at that and understand as to what is really happening or going on in that particular model, right? So that's what we're going to look at. We're going to start with the definition of financial modeling, right? Now, uh, in terms of the broad definition that is available, we're going to first start with the technical definition that is given on Wikipedia. It's the task of building an abstract representation or a model of a real world financial situation, right? This is a mathematical model designed to represent a simplified version of the performance of a financial asset or a portfolio of a business, project, or any other investment. In a general term, it means that it might mean different things to different users. The reference usually relates either to accounting or corporate finance applications or to quantitative finance applications. Quantitative finance applications will typically look at this in the form of risk analysis or risk analytics, as we call. Accounting and corporate finance is going to look at all areas around project finance, around valuation, around financial statement analysis, around anything else that comes up, right? And then quantitative finance could also come in terms of modeling around debt, etc. So that's basically what we mean by a financial modeling exercise. In simple words, we are saying is that the process of solving a problem in the financial services world using a tool like Excel is known as financial modeling. So we're using a tool like Microsoft Excel to solve a problem in the financial services world, right? It could be any problem across the spectrum, length and breadth of the financial services world that we are trying to solve. Let's think about a few such problems, right? If I were to ask you, just give a problem that a financial services professional is likely to face, then there are 20 problems that might come to our mind immediately, right? Financial statement analysis is a problem. Valuation is a problem. Project evaluation is a problem, right? Calculation of cost of capital is a problem. Identifying credit worthiness is a problem. So credit analysis is a problem. Then you could look at home loan EMI calculation as a problem. You could look at credit card EMI as a problem, right? You could look at risk management as a problem, or you could look at things like pricing of financial instruments as a problem, right? There could be 20 problems that could come out, and all of them can practically be used can be solved using a tool like Excel. And that's the power and intelligence of Excel that is available here. That so far what we have learned in Excel are the basic building blocks. Now we are going to extend this entire analysis in terms of solving problems by creating relevant models, useful models, scalable models, right? That's the process of financial modeling. The applications could go beyond what we have just discussed. Primarily, key applications would be business valuations, scenario planning, capital budgeting, project finance, financial statement analysis, risk management, portfolio evaluation, data representation, right? These are the major applications that you would find. And you could think about various segments in terms of, let's say, business valuation. We're trying to build a model of a company, trying to value it. Scenario planning in terms of, let's say, a company is going to take a certain decision and there are multiple possibilities in outcome. Scenarios could be used to kind of analyze that. Capital budgeting, where should the company allocate the money? Financial statement analysis, calculation of ratios and identification of trends. Project finance, in terms of forecasting, in terms of actually evaluation of projects. Risk management in terms of figuring out if a portfolio of stocks can go up or down. Risk management in terms of simple things like pattern recognition, right? So you could have reams and reams of data, and Excel could be used to solve some of that as well. Portfolio evaluation, data representation. Once you already have the data, you could possibly use that data, represent that data in the form of charts, in the form of tables, in the form of useful data tools, which could be then picked up by another segment to analyze that, right? Those are some of the applications of financial modeling. There could be more applications. Things like derivative pricing, for example, could come under financial modeling. Now, what are the key features of a financial model? Now, unlike simple spreadsheets or simple Excel files, a financial model is much more. It is structured. There is a logical flow of assumptions, inputs, and calculations and outputs. So you put in the assumptions, you create inputs, those inputs result in calculations, and then you finally reach the outputs. It's a structured flow. You don't start with the output and say, okay, this is what a financial model looks like. It is dynamic. Thus, it allows the user to change the inputs and observe what happens to outputs. This allows for sensitivity analysis. So always remember that a financial model would be dynamic in nature. Data will not be hard coded, right? And we will understand what do we mean by data not being hard coded in a moment. It is more readable. So if I make a financial model and give it to you, you should be able to read it and understand what that model is, right? Simple spreadsheets don't do that. We just put in numbers and we try and hope that others understand that. But in real life, uh, financial model should be readable. It should allow for error handling. So if someone inputs an incorrect number, it should tackle the error and address, represent the data in terms of a proper representation and not really show an error there. And finally, and most importantly, a financial model should have an objective. Without an objective, there is no real point in creating a financial model, right? So it is absolutely necessary for a financial model to have an objective, which is basically why is it needed in the first place? What is it that we are trying to find out using this particular financial model? It is very important for us to identify and outline this as we begin, right? You will note that when we start building financial models, once we have defined the objective, it becomes much simpler to ensure that it is structured, it is dynamic, it is readable, and it tackles error handling because we know what is it that we want to find out. We know the purpose of the model, right? Also remember that in today's world, collaboration is very important, which means multiple people across multiple teams might be working on the same project. Therefore, it is important for financial models to be accurate and reliable, flexible, and user friendly, right? What do we understand by these terms? Let's try and look at a few examples, preliminary examples to understand what do we mean by these terms. So let's look at this Excel file and let's say it starts with this kind of a number. Now, it doesn't really look good in terms of viewing. We don't really understand what these numbers are. Let's do this. So when we read this, we probably get a sense of, okay, we are trying to look at number of motorcycles, price per bike, and revenue. So multiplying the motorcycles with the bike should give me the revenue number broadly. And then there are some costs given here, right? Now, immediately as you see this, the first problem that comes to your mind is the problem of decimals, right? You look at this number and you find that There are some where there are 2 decimal points, there are some where there is no decimal point, then there is 5 decimal points, 1 decimal point, 3 decimal point, and 6 in one case. Now what does that do? What it does is that this number and this number are similar, but for some reason to the naive eye, the second number will look bigger, right? This is only slightly higher than this, but it appears much bigger because we are not able to really look at it and understand, okay, where is the decimal and what is the size. Always remember that in a model, in a financial model, it is a good practice to ensure that the decimals are evenly spread, right? Which is, if you're using 1 decimal point, use 1 decimal point for all numbers. If you're using 2, use 2 for all numbers. It's always a good idea to also use this separator, the comma separator here. So it's a good idea to use this separator. When you click on that, it by default adds 2 decimal points. You can remove the decimal points based on your requirement. Looks much more readable, looks much more understandable, right? And that's the first learning in financial modeling, that it is absolutely necessary for us to have clean decimal representation that comes here in a file, right? So that's the first thing that comes up. Look at another case. Calculate the revenue of a cinema hall with 500 seats, average ticket price of 200, 5 shows a day, 35% occupancy, right? So what is the calculation we are going to look at? That's going to be 500 into 200 into 5 shows a day into 35% occupancy rate and into 365, right? Now that's the calculation. We've done that calculation here, right? Now you might look at it and you might just say, okay, there are like 4 decimal points. There is no data point that comes in. So the first thing we need to do is make it more readable, right? Wherever possible, convert it to either larger numbers. Revenue kind of numbers probably should be converted to millions, etc., right? That's the first learning that comes. However, what if tomorrow we get to know that the ticket price has gone up to 220? So either I go into this, figure out which one of these numbers is the ticket price, and then try and make a change here to 220, or I make this a dynamic model. How do I make it a dynamic model? I put 500 here, I put 200 here, I put 5 here, I put 35 here, and then link. So I do 500 into 200 into 5 into 35. 35, remember, is percent. So I divide by 100 and I multiply by 365 because that's the annual number that we are looking at, right? So that's the number we get. Now let's say the ticket price goes up to 220. It's at least become dynamic, right? Is it readable? It doesn't look readable, right? Because we have not added the labels, right? So we should be putting seats, we should be putting ticket price, and we should be putting shows, we should be putting occupancy, right? And that gives us the revenue. It still does not tell us a lot of things, right? It's probably better than the earlier calculation we had, but it's still not really too useful in terms of our understanding. We might want to insert a column here. Why? Just to put in the units. Ticket price in what? Is it dollars? Is it hundreds? Is it rupees? Is it just numbers? So we can now put the units and calculate this in INR, right? Even then, it doesn't look good because occupancy is 35%. So it's probably a better idea to put it as percent and in the formula make a change to remove this 100, right? So it basically shows the number as it is in terms of what is the correct representation of the number. Now we change this to 180 or we change this to 220, we will automatically get the answer there, right? This now looks a much more readable and dynamic model. If you want, you can convert this in terms of, let's say, millions dividing by 10 raised to power 6 and add a couple of decimal points. So 63 millions and in which case you will want to write INR million here because that makes it dynamic, that makes it readable, and that makes it flexible, right? It is user friendly as well in terms of someone else opening up this model. It gives an impression that they can understand what is happening here, right? Unlike the first calculation where we started with just putting the numbers in without any sense there, right? It's also always good to put the headers, names, etc. around these, format it well so that people can look at it and they can kind of understand, okay, what are distinct blocks. So this is a distinct block, which is the input segment. If you note this, I can put in inputs here, and this is the output, or this is the calculation, right? And I can kind of put them right in the middle in terms of where they are. Maybe inputs can be put in with a different color, outputs can be put in with a different color. It's just to make the model more readable, understandable, right? That's the importance of a financial model. That is what we are going to build on as we move on into this segment, into this unit. As we come to the end of this particular video, a couple of quick questions. Define financial modeling in simple terms, and what do you think are the major features of a financial model? In subsequent sections, we will do a quick recap of some of the Excel functions that we've already learned in previous semesters or previous terms. And then we kind of build on to the idea of how do we go about creating a financial model, a relevant financial model, a good detailed financial model, right? Thank you.